Hi, good day everyone. Today I'm going to present the paper entitled The Key Technology Toward the Self-Driving Car. It is a paper written by Shanfeng Zhao, Hodong Liang, and Shusha Chen of the School of Automotive and Transportation Engineering, Shenzhen Polytechnic in Shenzhen, China. My presentation is divided into several parts as shown here in the following slides. First is the introduction, followed by the car navigation system, global path planning, vehicle control, main research, institution of self-driving car, trend and discussion of self-driving car, and key takeaways. The main characteristic of self-driving car is obviously transporting people or objects to a predetermined target without humans driving the car. It is said to be that technology of self-driving car represents the level of scientific research and industrial strength of a country. In the next slide, you will see that there are actually four levels of self-driving car according to this research. First is the function-specific automation. Individual vehicle controls are automated, such as electronic stability control or automatic braking. Level 2 is the combined function automation. At least two controls can be automated in unison, such as adaptive cruise control in combination with lane keeping. Third level is the limited self-driving automation. The driver can fully cede control of all safety-critical functions in certain conditions. The car senses when conditions require the driver to retake control and provides a sufficiently comfortable transition time for the driver to do so. And lastly, the full self-driving automation. The vehicle performs all safety-critical functions for the entire trip, with the driver not expected to control the vehicle at any time. As this vehicle would control all functions from start to stop, including all parking functions, it could also include unoccupied cars. So this paper introduced a new classification of the self-driving car, which is not based on its level of automation, but according to the function realization. So this classification is able to clearly express the technical requirements of a self-driving car. It is inspired by the operation steps of human driving vehicles and is easy for researchers to understand. As you can see in this image, the core technology of self-driving car is classified into four key parts, which is known as the car navigation system, the global path planning, the environment perception, and car control or vehicle control. So let us discuss the technology one by one. In the car navigation system, Geographic Information System and Global Positioning System or GPS are equipped to receive the location information such as longitude and latitude from the satellite. So the location system, its main purpose is to determine the vehicle's location, which generally can be classified into relative location, absolute location, and hybrid location. The relative and absolute location is facing disturbances such as vibration during moving, weather conditions, or urban environments, so that deviation between calculated location may occur. So the hybrid location, which combines the characteristics of the above two locating methods, is the most common method used in obtaining the position of a self-driving car. Electronic map or EM is used for digital map information storage, which mainly includes geographical characteristics, traffic information, building information, traffic signs, road facilities. And nowadays, most of the EMs which are used in a self-driving car are the EMs designed for humans. It is actually expected in the near future that EMs for self-driving cars will be developed. Next is map matching. The map matching, which is the foundation of the path planning, calculates the car's location by using the geographical information from GPS or INS, and the map information from EM. So during the calculation, the advanced fusing techniques is employed to fuse the longitude and latitude or other coordinates information into the EM. So from the practical viewpoint, the output of car location should be accurate and time efficient. In this regard, it is an important issue to find a good method to fuse the information from GPS and INS. So next is the global path planning. Global path planning is used to determine the optimal driving path between the start point and end point. The typical path planning algorithms are employed to fuse the EM information and calculate the optimal path. The global path planning is at mature stage and already implemented commercially on a large scale. In fact, there are several algorithms already existing and is being used by the self-driving car. So they are the following: Dijkstra's algorithm, Bellman-Ford algorithm, Floyd-Warshall algorithm. So because of the complexities of these algorithms, we will not discuss them here. So environment perception. Environment perception is the second module of a self-driving car. To provide necessary information for a car's control decision, the car is required to independently perceive surrounding environment. The major methods of environment perception include laser navigation, radar, and visual navigation. So during environment perception, multi-sensors such as these three are deployed to sense the comprehensive information from the environment, which are then fused to perceive the environment. Among the sensors, the laser one is utilized for bridging between the real world and data world, while the radar sensor is used for distance perception, and the vision sensor is used for traffic sign recognition. So next is vehicle control. So vehicle control mainly includes vehicle speed and direction control. Generally, the functionalities of vehicle control are the vehicle status perception and the development of vehicle's control method. As you can see in this image, to achieve speed and direction calculation, so the EM here, information, including environment perception here, and the vehicle status, the driving target here, traffic regulations, and driving knowledge are fed as input into the perception module. Then the vehicle control algorithm performs the calculation of the control target, which is then passed in the vehicle control system. Finally, the vehicle control system execute those instructions to control the vehicle's direction, speed, or horn. So the main research institute of self-driving car. The main research institutes can be found out by introducing several competitions. First is the DARPA competition, or rather the DARPA Grand Challenge, which was held in DARPA in 2007. In 2004, 15 teams joined the first challenge that was held in the Mojave Desert region of the USA. The goal of the challenge was passing through 240-kilometer desert. However, no team could complete the task until 2005, where 5 teams completed the task smoothly with the jumping completion time of 6 hours and 54 minutes. Different from the previous two challenges, the third DARPA challenge here in 2007 was an urban challenge in which the test environment was an urban road. The second trial is the European Land Robot Trial. The first LROB took place in the infant training area near Hammelburg on May 15 to 18, 2006. Unlike the DARPA, European robotics bridges the gap between the industry and research in the field of ground robotics. The robotics competition also held in a game form, which includes the military and civilian form, and these two forms held in turn every year since 2007. But Google is the most famous agency in area of self-driving car. Google self-driving car is developed by a team headed by Sebastian Thrun, who is the director of Artificial Intelligence Laboratory in Stanford University. The accumulation of Google self-driving car technology began in 2005. The first driving license was issued to Google self-driving car in Nevada, USA in May 2012. By the end of 2014, the project with 8 self-driving cars has been tested on more than 700,000 kilometers, even if the road covered urban, highway, mountainous roads, and various roads. No proactive accident happened. Before the Christmas Eve of 2014, Google announced the first real build of their self-driving car. So trend and discussion of self-driving car. We know that the experimental prototypes of the self-driving car have been developed. So some typical self-driving cars have been tested on more than 1 million kilometers, and the test for driving license for a self-driving car has been issued by some states in USA. However, we should know the realization of self-driving car is not only influenced by the self-driving car technology, but also by the vehicle cost, social habits, human psychology, and law. Therefore, there will be a long way to go for the entire commercialization of self-driving car. At present, self-driving car actually configures many sensors that are non-existent in a traditional car. So for instance, the lasers and vision sensors used for environment perception are the typical key sensors. These key sensors are expensive and have high requirement on using condition. Moreover, the service lifetime of the sensors will be greatly reduced when they are installed in the moving car. In addition, it needs time for the social habit of humans to accept the self-driving car. For instance, the share of self-driving car among the people, the development of automatic supporting facilities for self-driving car, energy compensation, the human psychological acceptance degree for self-driving car, and the development of the law to deal with the traffic accident on self-driving car. So for the key takeaways, the paper is very helpful in educating individuals to the key technology of self-driving cars. It divulged deeply on the core technology and defines them really well. I was looking for a conclusion or recommendation section, but it does not have any. The whole paper itself is a recommendation of sorts, which encourages the industry to look deeply on the mechanism, devices, algorithms the self-driving car requires for it to function fully. I also appreciate the fact that the authors did not focus on automation, but decided to choose a different path to educate. That beyond automation, these smart systems is a chunk of micro things built together into one. It's also worth mentioning that the paper points out several sociological aspects such as the law, human psychology, and social behavior, which affects the whole system. What I thought should be improved is that if the paper discusses a little bit of history of self-driving car and how the core technology has developed over time and how the core technology will recover if at some point communication between the mentioned technology fails, how the system will recover to ensure safety of the passengers and everyone around that self-driving car. So that's it. Thank you for listening and have a nice day.